Why, hello there, and welcome to Hey Productive, and we're doing statistics and mathematics. I'm Will, I'm on my own because it's a maths video and no one else likes maths but me, because I like it, because it's nice. Statistics S1 for Edexcel, but AQA apparently does it as well. I was only informed yesterday, but that's just lovely. Number 1, lesson 1, representation even, and summary of data. Histograms. There are no gaps between the bars. The area is directly proportional to the frequency, so the total area is directly proportional to the total frequency, which you would put as area equals a constant times the frequency, where k is a constant, and that's how you find out one or the other. The height of the bar, or the frequency density, is equal to frequency over class width. That's all you need to know, really. That's it. Stem and leaf diagrams. When constructing a stem and leaf diagram, the data must be in ascending order from the middle, or the stem, have a key relatable have a key relatable to the diagram, have at the end of each line the amount of numbers in the line or the frequency labelled in a bracket, and have a clear title, or if back-to-back, 2 titles. 2 spelt wrong if you're looking at that. Mean, mode, median for raw data. The mean, you should know, you just add them up and divide by how many there are. The median, you divide them by 2. Really divide the amount, how many there are by 2. If it's an integer, so a whole number, then take that number and then the one above and divide it by 2, and that's your median. If not, then round up and take that number. The mode is the number that occurs most often. It's that simple. This is the same for data in a frequency table, but you just remember to use f of x, where f is the frequency and x is the midpoint. And that's it, really. Isn't that lovely? The mean and the median for group data now. The mean is the same, using the midpoint as x, as I said. The median, use linear interpolation, assuming the data is distributed evenly throughout the class. You might need to say that. B plus, well, you can see the letters, so I'll read it out as it is, which is the lowest class boundary plus the total frequency divided by 2, or if it's a quartile divided by 4, or 3, yeah. Minus the frequency below the median class divided by the frequency of the median class, all multiplied by the class width, and add that onto B. So that's what you got to do, really. Measures of dispersion, like quartiles, you just adapt the formulas from the median formulas. So for the lower quartile, you divide it by 4 instead of 2, and for the upper quartile, you times it by 3 and divide it by 4. It's that simple. Percentiles, deciles use adapted formulas from the median. They're just, yeah, they're the same thing, really, kind of. The range is the largest value minus the smallest value, and the interquartile range is the upper quartile minus the lower quartile. For the variance, you need to know it's sigma x squared over n minus the mean squared for raw data. Or if it's in a frequency table, use x as the midpoint, and it's sigma fx squared over sigma f minus the mean squared. And for the standard deviation, you root that. You will need to know that. You won't be given that in the exam. I know, that's horrible, isn't it? Isn't it awful? Box plots now. Don't forget to put a title and label the 3 quartiles. Put the lowest value and the highest value. If there's an outlier, mark it as an X, and then have the second highest value as the end of your whiskers, if you like, if you call it a box and whisker. But why would you do that? Yes, and an outlier is the upper quartile plus 1.5 times the interquartile range, or a lower quartile minus it. That's simple. Show you working, kids. Skewness. Yeah, for a histogram, if the mean is less than the median, which is less than the mode, then it's negative. If the mean equals the median and equals the mode, it hasn't got any skew. And if the mean's more than the median, more than the mode, it's positive. For a box plot, if the that's just a possible way of saying if the first bit of the box is bigger than the second bit of the box, then it's negative. If they're the same, it's hasn't got any skew. And if the second bit of the box is bigger than the first bit of the box, then it's a positive skew. So that's lovely. Probability now. Venn diagrams. The amount in each full circle represents the probability of that letter. The amount in between circles represents the probability of them happening at the same time. There must be a box around it, and usually there'll be a probability of none of the letters happening, which must be inside the box. But you can put it anywhere, just not inside any of the circles. The addition rule now. The probability of A or B equals the probability of A plus probability of B minus probability of A and B. And you can swap those around and rearrange it. And is shown in a Venn diagram by the overlap. So naturally you count that twice if you're adding probability A and the probability of B, which is why you take it off if you're finding the probability of either of them. Oh, there we go. There's a rearrangeness of the equation. The product rule. This can also be seen in the formula. The probability of A given B is probability A and B over the probability of B. But you can use it as the probability of A and B equals the probability of A given B times the probability of B. Doesn't matter. There are often questions on conditional probability, which is the reason why you might need that. Tree diagrams, you just multiply along the branches to find the total probability. You should have practice with that. If the events aren't independent, then remember to just to adjust the second or third events to fit. For example, if they take a ball out of a bag and they have 9 balls in the bag, the second one, if they don't replace it, should be out of 8 rather than out of 9. In a tree diagram question, it's easiest to work out all the total probabilities at the start of the question to put it on at the end of the tree, which will make the rest of the question a lot easier, but make sure you show your full working. So write out all the rules or the formulas and then put in your data and rearrange, etc. etc. Independence and mutual exclusiveness. No one likes this. If A and B are independent, then the probability of A and B equals the probability of A times the probability of B. It's really that simple. One doesn't affect the other. So the probability of A given B is just the probability of A. Yeah, really. If A and B are mutually exclusive, then they can't happen at the same time. So the probability of A and B equals 0. So the circles, if it's a Venn diagram, will not touch. They can't happen at the same time. That's what I just said. Correlation and regression now, which is always fun. The product moment correlation, coefficient. If I'm not given SSX, SYY, or SXY, then you'll have to fill out a table like that. It's quite unlikely, but you should at least practice once in your revision how to do it. And just remember, you should have X, the Y value, X times the Y value, X, the X value squared, and the Y value squared. And then you can find out using the lovely, okay, they're horrible, equations there. Isn't that just beautiful? And all of that is given in the formula booklet. So it's just a matter of applying your basic knowledge. Linear regression. Finding B, you divide SXY by SXX and then sub it into Y equals A plus BX, where Y and X are the mean values to get A. And then you write it in the form Y equals A plus BX, which is your regression line. So just remember to plug in the mean. And even that is given in the formula thing. So it's not really hard. Coding is a way of making numbers easier to deal with. As long as you apply the coding to a whole set or a row, it has no effect on the correlation coefficient. Fractional numbers reverse the coding. So it might have, say, P and Q, and then it might code it to be X and Y, and then you'll find the formula in Y equals A plus BX. And then they might ask you to have it in forms of X and Y in which you have to decode your formula. Which can be a bit tricky, and you might have to, yeah, that's it. Explanatory and response variables. Explanatory or independent variables are X. Basically, it's the experimenter's choice how they do that, and the response or dependent variables is the Y values, and so the Y values depend on the X values. You just need to be aware of what they are. Discrete random variables. Discrete random variable is a numerical outcome from an experiment. These must be discrete values, and each outcome has a probability associated with it. This can be described with a probability function. A set of all possible values of a random variable together with associated probabilities is called a probability distribution. The function that describes how the probabilities are assigned is called a probability function. For example, of a probability distribution, the sum of P of m equals 1, and that's an example. So that's an example of a probability distribution there and the probability function. Cumulative distribution function shown by the notation f of x. Using example, f of 3.5 will be the probability up to and including 3.5, which is a 6 plus a 6 plus a 6 equals 3 6 in this case. So you don't go up to 4, you don't round it up because it's up to and including, and 4 is not up to, that's over, so you don't do that. The mean of a discrete random variable shown by the notation e of x, which is the mean, really. This is the sum of the two rows multiplied together. So 1 times a 6, 2 times a 6, 3 times 6, all added together. In this case, it's 21 over 6. If you have the notation e, a of x plus b, you just do what is done to the x in the bracket to the e of x, really. So you times e of x by a, and then you'd add b. Variance, so notation var x, which is variance. This is the sum of the first row squared multiplied by the second row, all minus the mean squared. So it would be 1 times a sixth, 4 times a sixth, 9 times a sixth, all added up, minus whatever the mean was squared. And the rule that time for ax plus b in the brackets is you just ignore the b and square the a and times it by the, that should say var x and not e of x. I don't know what it says, e of x. Discrete uniform distribution. If each outcome is equally likely, the probabilities are the same, like the example that we used the whole way through. If you're very observant, very good. Well done. Have a gold star. Well, the probability of m is just 1 over m. So the mean can be found using symmetry. So it'll be the middle value, as you know from your Schooness work. The normal distribution, the last thing that you need to know. The mean equals the mode, which equals the median, as it is symmetrical. The area represents the probability and the total area being 1. The mean is a normal distribution, of a normal distribution is 0, and the standard deviation is 1. The notation, as you can see, by z squiggle n 0, 1 squared, is just saying z is a normal distribution with a mean of 0 and a standard deviation of 1. If it isn't squared, then make sure you square root it if you're trying the standard deviation. Phi of z is the same as saying the probability that z will be less than z, or the area below z. So questions you can get with that, you will need to use tables. To find the probability of a minus number, if the z is a minus number, you would do 1 minus the probability of whatever that minus number is, just positive. You have to make sure it's in the form of where the mean is 0 and standard deviation is 1. If it isn't, then you have to use the formula z equals x minus x being your value that you need to find probability from, then your mean divided by your standard deviation, and that will equal the z on a graph like that, where the mean 0 and standard deviation 1. And you might, if you know a percentage, then the smaller table will tell you what the z is. If the percentage isn't on the table, use the other table. So what the smaller little table you get in the formula booklet, that tells you the percentage to the right of your answer. So if you look on the diagram, the z, it would tell you if z was, I don't know, if it said that area from z to the right is 20%, you'd look up 0.2 in your smaller table because it tells you that way. Whereas with the other bigger table, it tells you information to the left. So if z was, in that case, 1.9, you look up 1.9 and that will tell you the probability to the left of z, and you'd have to take it off 1 if you wanted to find the area on the other side of it. I hope that makes sense. That's it. That is a whole other probability unit. That's everything you need to know, really, in that little video. It's very quick, but that's it. It isn't that difficult, I don't think. So just learn that, practice the questions, do past papers, and that's it. Thank you very much for listening. I highly recommend Decision or the core units or history when I actually have a friend, and psychology. Thank you for listening. Bye. Bye.